I'm Russ Dunnington, Department Chair for the diesel program. I know most of you, but I don't think there's a couple faces I'm not that familiar with. So what we do is we teach students to repair heavy equipment, heavy-duty trucks, medium-duty trucks, those types of things. And one of the areas that we teach is hydraulics. And hydraulics has always been, some people catch on to it really quick. Some people have a hard time understanding how fluids act with different speeds, different flows, different pressures, those types of things. So one of the things that we came across here very recently was a company called Labvolt, and they make all kinds of training aids, virtual trainers, real physical trainers for different areas within our industry. And this is the first term that I've used this, and it's working out really, really well. And what it is a virtual trainer. Years ago, when distance learning first started to develop and everything, and there was emails that went out and said, how can you do this in a virtual setting and such? And we always thought, well, they got to fix trucks and fix equipment. It's kind of hard to do that virtually. But we did find that there is aspects to that we can employ in our program. And so what we're looking at here is a virtual room where we can construct hydraulic circuits and then actuate them and make them do what they're supposed to do, or if a student doesn't do it right, it's not going to do what it's supposed to do. So what my students do is I give them an assignment, a written assignment, I explain what I want them to do, and then they do these as homework. Then they email them to me, and I drop them into a folder. Then when they come back to class, we have an actual trainer where it's the same as this, where they actually do it and make the system work properly. Once they've accomplished both the virtual trainer and the actual trainer, then they get credit for that particular program or assignment, okay? So we're going to build a very simple hydraulic system, and hydraulics are used all over the place in aviation and in construction. All the machines you see building the buildings around us and the roads, they're all hydraulic machines. So it's extremely popular or common in our industry, and it's one of the areas, that and electrical are the two areas that schools struggle with getting good foundation basics with our students. So I just clicked up here, and that gave me a table or a work surface, okay? So I can find the components that I want, and we're going to build this. So I'm going to go ahead and I'm going to put two work surfaces next to each other. And some of the students just love this. Some of them have a little trouble, but most of them really like it. Okay, so now I got a work surface. Now if I want to take a different view of that work surface, I can click on this little helicopter, and then I can move it around and put it where I want it to be so I have a good view of it. Okay, so the next thing I'm going to need is going to be our hydraulic power unit. Okay, so this is a hydraulic power unit, and again we have this in our shop. Okay, and one of the really cool features is if I want to know what this thing is and does, I can right-click on it, and I can get a cutaway view. So that's what it looks like inside. I didn't bring a pointer. We have a hydraulic pump, and we have a relief valve. We've got a filter symbol up on top that's not shown in here, and then we have pump pressure coming out and then return back to tank. So that's what's inside the hydraulic power unit. So I need to grab a couple manifolds. So I'm going to grab a manifold here, a 5-port manifold. And I'm going to put one here, so I just click it and then it sticks. And I'm going to get one more. Equipment. Okay, so I'm going to make one of these my pressure manifold coming from my power unit, and the other one my return manifold going back to tank. And if I put my little mouse there, it tells me what it is. So that one is my my pressure port. So I'm going to go ahead and connect that, and I'm going to connect this over to here. So now I have my two manifolds. Okay, my pump again is inside of the power unit. And what I want to do is make a hydraulic cylinder extend and retract. And I have a couple different choices on hydraulic cylinders, so I'm just going to grab one here. My contacts are a little, I have a new prescription in the mail, so hydraulic cylinders. There it is, cylinders. All right, thank you. Okay, so I'm going to grab that cylinder. I'm going to drop it in here. And I'm going to need a control valve so that I can make the cylinder go in and out and control the flow of the fluid. So I go to valves, and I need a directional control valve lever operated. Okay, so there's my control valve. Now, there's a relief valve inside this power unit, but I have my students put one in here anyway, because usually it's not in the power unit. It's usually remote mounted or in the control valve. So we'll grab us under valves. Valves. And so I need a relief valve. Okay, so those are the components that I need to operate this system, and now the students have to hook up all the lines, and then when they come to the class, they have to hook up the actual lines themselves, right? And if I put my little mouse here, so this is a pressure port, so I want to relieve the pressure back to tank if pressure gets too high, because fluids are virtually incompressible, and so a gear pump like that's inside of the power unit, it's going to move fluid regardless. So if you block off the fluid flow, something breaks. Blow the hose or you crack the pump in half. Not on here, in the real world, yeah. That's why these power units have an extra relief valve inside, so that doesn't happen. Okay, so this is pump pressure, so I'm going to hook that up to my manifold. This is return. And then this is work port A and B. Doesn't matter which one goes on which. And if I want to take a look at my control valve, so here's my control valve. We have work port A, work port B, pump and tank, and this is called a closed-centered hydraulic valve, meaning when it's in center, no fluid goes through it. Okay, and if I shift the valve, okay, the cutaway shifts too. So I can see that when I shift the valve back and forth, one work port lines up with pump. The two top, we pump right there, flows through, goes to work port A, and then work port B goes to tank. And I go back to center, and I pull it this way. Now pump is going to work port B, and tank is going to work port A. Okay. So I'm going to go ahead and turn on the power unit. Hopefully nothing will break, blow up. I got my hose in the way. There. Turn the power switch on. Now, if I look at my, there's my filters up on top. Yeah. So my pump is pumping fluid out, okay, and it's coming back to tank, and the way it's getting there right now is through this relief valve. This is called a pilot-operated relief. Okay, so fluid is going to the directional control valve, but it doesn't have any place to go. Okay, because it's coming in here where the pump is and has no place to go. So pressure builds and it goes over this relief. Now if I move the lever, okay, now the hydraulic cylinder, go ahead and drop this over here. Now my hydraulic cylinder receives the fluid until it runs out of travel. When it runs out of travel, there's no more place for the fluid to go. So it goes over the relief valve right here on the right. Okay. I can also change the pressure. So here is right now the value of the spring, the pilot spring on the pressure relief valve is weaker than the value of the spring in the relief valve in the unit. But if I was to, it's basically whichever one is weaker is going to open first, right? So it's going to leak through whatever takes least path resistance. So whatever it can open up easier is where it's going to go. So I can change that by dialing this pressure up, and see I'm making the spring stiffer. And now it's going over the relief valve in the power unit because it's taking least path resistance. Okay, any questions so far? Okay, now let's talk about that relief valve for just a second. one of the principles of fluids is when there is flow across an orifice, there's a pressure drop, and when there's no flow, there's no pressure drop. So basically, if I had a hose and I capped the end of it, and I put line pressure of 70 psi to it, I could measure anywhere across that hose, and I'm going to read 70 psi. As soon as I start to flow, however, then the pressure is going to drop, and depending on the flow rate, the viscosity of the fluid, and of course the size of the orifice is going to determine how much pressure drop is going to occur. Okay? That's how this valve works. Right now, we have a equal force pushing up on this surface area, okay, and pushing down on this surface area. They're both the same size, so there's no force differential, and if there's no force differential, there's no movement. But we can change that by allowing flow to occur at this orifice. So this is an orifice, okay? And so if I dial this back down, the way this valve actually works, and that's why it's called a pilot-operated relief, is this spring and this little ball up here is the pilot. Okay, if I turn that down, a little more, okay, now we're going through both because they're set at the same value, and if I turn it down a little bit more, we're going to close the relief valve in the power unit. So what's actually occurring here is as we have flow across that orifice going up to the upper end, that's causing a pressure reduction on the top side of the valve. That's what causes it to shift. So the pilot valve is a trigger for the main valve. It's starting and stopping flow, and by starting and stopping flow, it creates and stops a pressure drop from occurring, and that's how the valves shift. And lots of our components work under those types of principle. Okay. Now let's see here. Let's go ahead and, oops, wrong mouse. So we're in the process, like I said, we have the real trainer, and there is some additional software we can purchase. So I get to kind of get you into it for free. This is free. All my students download this and put it on their computers. Okay. But some of the pressures, like if I hook up a pressure gauge here, I can't see the actual pressure because we don't have the additional software yet. We wanted to try it out, see how it worked, see what kind of glitches we would have, and so far we've worked out really, really well. Okay? But this is the kind of stuff we do in our program over there on a daily basis, and I was asked to share this because it's kind of new and it's kind of different. So, thank you.